Um, Thanks so much, Jeff, for being willing to joining us. Initially, we had actually last time we did the hackathon. It was the opposite situation. We had like 12 judges, and then there were like three of us presenting. But this time, you're the only judge, so we are really excited because then we can go much deeper into the conversation. And so we're really looking forward for this conversation. And also this format, maybe we can do it a little bit different. Instead of giving you a lot of context, we could basically just do the presentation that's supposed to have most of the context. And let's have much more time for the conversation. But before we jump into it, still let's have a quick round of introductions. And Rob, would you like to introduce yourself?
Yes, I'm Rob, and I'm part of Safecast. I've been from Safecast from the beginning, and I live in the mountains in Nara, and I've been in Japan for a long time, and I enjoy designing and making software, making things. Yeah, that's
Pleasure
it.
to meet you, Rob.
Yeah, nice to meet you too.
Josh, would you like to introduce yourself?
Sure. Hi, I'm Josh Kim. I'm in Denver, Colorado. I'm a software or semi-retired software developer and software engineering manager.
Yeah. Nice to meet you, Josh.
You too.
And hi, I'm Jody. I do design and facilitation, and I'm based in Singapore. Pleasure to meet you. Do I have a fun fact? I live in Pongo.
Oh, you live in Pongo, okay. Great. Nice to meet you, Jody.
And
Wait for
I like to.
Alex.
Yes.
Hello. Sorry for the camera nausea. I'm Alex Hornstein. In the US. I run a small group called Wild Lives that does children's nature education, and I spend a lot of time designing cameras for filming wild animals in situ.
Nice. Nice to meet you, Alex.
Alex, by the way, Alex, you're friend of Akiba? Chris, what's his name? Chris.
Akiba Wang?
Yeah.
Yeah, we know each other from back in Shenzhen, like a decade ago.
That makes sense now.
For the little background, Alex and Sean Frame, they were good friends we met on the train going to San Jose to the Maker Faire, and they were building a machine that picks and places solar panels to make like custom solar panels. And then they were the first and the biggest tenant for Maker for many years, and they made the like most advanced holographic displays, I think, in the world.
Wow.
And so, and then he built a whole community of people who can post basically like 3D videos, and among many other companies that he started. And so, yeah, also very technical. So yeah, and also incredibly creative. So yeah, super happy to have you.
I've had the privilege of being very close to Cesar over the last decade or so. So it's been a delight to watch Cesar's work and ours intersect whenever possible.
Nice.
It's a pleasure. Jeff, would you like to introduce yourself?
Yeah, sure. Just a quick introduction. I'm a colleague of Cesar. I'm an associate professor of design at Singapore Institute of Technology. I also co-own a design consultancy in Singapore and in Amsterdam called Chemistry. We've been around for about 23 years, and we do a lot of work in innovation consulting, transformation, UI, UX, and probably in the last like 8 years doing more regenerative design projects. So working very closely with the Technical University Delft, as well as the Circular Economy Foundation, and we brought Circo methodology to Singapore, which is looking at circular products and products that flow. Yeah, nice to meet everyone.
Nice to meet you too.
Thanks so much. So basically, we have two sides of the group. We have Alex and Jeffrey, who are going to be acting as the judge, and we're going to be presenting to you. So I think the presentation might be about 10 minutes. So maybe we'll present, but please write down your question, and most of the time I think it's going to be about discussion. All right, so I'm gonna start sharing the screen and we're gonna get started. Okay. Okay, so this is the second edition of the Climate Hackathon, Climate Data Safe, sorry. And now the last time we were doing concept, and this time we built a demo. So hopefully we're gonna demonstrate it to you. Okay, so the planet and the people are suffering. There's more climate extreme events. Just recently in LA fires. But the problem is what we also have is that we have more and more data. So every 2.5 years, the amount of data that transfers over the internet is double. So it's exponential. And below, this is the curve of the trust of people in government. So the trust in government is really dropping, and by extension, the trust in cultural institution or research institution is also dropping. Last time the current administration got into power in office in 2016, climate scientists got to see the climate science defunded. They got to see their research censored. So the word global warming and climate change were censored. They were no longer allowed on the government website. This is quantified. This is not just a claim. This is actually like substantiated and it's well documented. And with the project 2025, they've said that they want to quote them, dismantle institutions like the NOAA. That is one of the biggest, for like climate science. So this is the context in which we are. Maybe I'll let Josh elaborate on this one.
Yeah, I mean, just to reiterate some of the same points or rephrase them. Obviously, climate change presents unprecedented challenges across the globe. Climate data and access to it is under political threat. Climate data is difficult to find. It's difficult to access. It's not in an ingestible format for most people. There's disparate data in various formats, in various sources. It's very hard to correlate and combine. As Cesar mentioned, public trust is falling, and it's hard for researchers and citizen scientists to make their work easily discoverable and publish it to a broader audience. I guess should I present this one as well? So just sort of a brief mission statement here. So what we're trying to build is a universally available, reliable, trustworthy, and accessible source of historical climate data, model outputs, and other environmental data that is protected from tampering and censorship, and leveraging open source tools to do so. So, our overarching goals here are universal accessibility, both sort of globally having the data available for people to access, as well as putting it in formats that are ingestible and understandable for the widest audience possible. Verifying and trust data, making sure that people are sure that the data has not been tampered with or changed in any way. It's consistent over time and source. Building a system that's both flexible and extensible. We don't exactly know what the use cases are going to be. We have some ideas, but these evolve over time, so we have to be ready to change them. So we have to build a system that is easy to build upon and change as needed. And then finally, building a project that isn't a one-off. It is a sustainable, ongoing effort that can exist for the long term. So we've come up with sort of these three pillars, for lack of a better term: sharing, trust, and sustainability. Along those lines, as far as sharing goes, making it easier for people researchers, climate scientists, citizen scientists to upload data or add it to our repository. Make sure the data is replicated around the world, both for availability and to circumvent any sort of censorship. And then finally making analytics that are easy to understand for the broadest possible audience. As far as the trust goes, again, we get back to the replication, automatic change detection, knowing if these data sources have been tampered with or updated unexpectedly in any way. And then making sure that each copy matches the others, which will be a very surefire way to see if things have, if someone's messing with the data. And then finally, even our data, making sure that it's distributed and replicated around the world, so that, there isn't a single point of failure in the system. And then finally on the on the sustainability front, figuring out revenue sources to keep, the thing hosted, finding both, large sort of donation sort of things, finding collaboration opportunities, micropayments maybe, and subscriptions are a revenue source we could do, and then also making the system itself as cheap to maintain over time as possible. The slower you're spending money, the less money you have to bring in. This diagram sort of lays out our idea for a system architecture. The main thing is that we have this metadata index, which is a core DB. It is accessed either through an API server or a web front end. For most people, the data itself will continue to be hosted on the cloud. For various things, we're basically building an index of where that data can be found and that is consistent between sources, and then also having the ability for hosting the data on torrents, sharded data that can be stored by anyone with the server. Another interesting part of the system here is this verification daemon. That is the thing that is going to go through and make sure that the data is consistent over time and between sources. There's a link here to a more fleshed out design proposal. You can read it at your leisure. And I think that's your slide, Cesar.
Yes, actually, so what we want to put out there, so this is already part of the prototype, is a screen capture of the manifesto, in which we sort of wrote a constitution of how, what is the vision, the mission, the values, the specific goals. So it's already quite well developed. And also by which values we're going to operate and make decisions together. So it also gets quite operational, and which kind of data we want to take on, what kind of license we want to take. So all of this is already quite clearly written. What we want to do next is that actually so far it's been mostly like IoT and us, like citizen scientists that have been working on this. But so far we have a bit struggled to bring in climate scientists in the group. But this is the people that we really want to bring in the group. But I think it was because we work with a very subset of radioactivity data and air quality data. And actually those two are not like directly usually correlated with climate science. But what we want to do now is to build something of value proposition. We want to bring climate scientists that will have those data sets. So between now and the next climate hackathon, we are already like infiltrating a bunch of climate scientist Slacks and trying to understand the challenges that they have and just getting them to join. So now we are starting the sort of the demo. The people that we're trying to bring in, this is the experience that we want them to have. So climate scientists or citizen scientists, people who are producing environmental data, will go on the website and there's a simple form that they can use to upload the file on the hot server. But this will then be verified. So they enter the metadata. We have a project management system basically where we would have a review process. So several of us will become the small committee. Eventually, the idea is to replace some of those by automation and recognizing maybe some patterns when the data is more trustworthy or if there's no anomalies in the data. So maybe we can automate some of that. The next step is hashing the data. So before we torrent it, is that so in this case, we use a third-party software for hashing and torrenting, but maybe down the line, we may be creating like a folded or SETI at home sort of client where all these functions that we are describing would be built into one client that would probably be cleaner. And also like this, we can really control more what's happening and the speed and the memory and everything. Then we generate the we generate the torrent, sorry, attached to a torrent tracker. We can use existing public torrent tracker. So this is free. The idea of this is that if every 2 years, 2.5 years, sorry, the amount of data doubles, there's no amount of money that's gonna allow us to host all the world's climate data. We're not gonna grow fast enough. So the idea is that torrent could allow us, because most of the data is still quite exotic. So we want to cache the really hot data that a lot of people want, but most of the long tail data, we just want to keep it in the cold storage as torrents. The next phase is to have an index. So this is where I think we're going to be spending most of our time as an organization, is to, once we have received the data, to index it, create standard formats that can be used for exporting this data or reading it through APIs, and then creating good visualization tools for collaborating and getting people to be able to access this information in a clean way. We've been very influenced by Joshua at the beginning was saying, like, why instead of hosting all the data, you focus on indexing it, just like making the search easier, so that people can know, okay, this is trustworthy data, it's highly rated, he's got the right formats, I can parse it and so on. Yeah, so where we are now, so maybe I'll continue. Where we are now is that we are at the second hackathon. The first one was really about the concept. The one that we have now is about design and prototyping. So we know that we've used third-party tools, and it was just a 48 hours hackathon. But the idea is that we start to prototype with existing tools. We use Notion in this case, but next we'll probably build our own database so that we're not going to be dependent on AWS, because Notion also runs on AWS. So that it's completely portable, and we bought some decentralized domain, for example, so it could be impossible to take the website down, and testing some of our assumptions. So the idea between now and the next one is that we want to build a simple version of this big database, this big index, and get climate scientists to join next time to actually come with the data sets. We could stress test some of our ideas. We've also built a crowdfunding campaign on GoFundMe. We just literally just this morning, just to sort of see if there's traction as well from the population. We have built 5 different social media channels, the biggest ones. And we've talked to people who are strategists for climate funding. So there's this guy called Eric Berlot that we talked to, and he's basically helped us to identify the big pools of money where we could tap into if we wanted to build such a system. So we also want to talk to some of the founders and start to write grants and application to build the system. Action call. People now will be able to go on the website and attend and join the next hackathon. We've created this database of our CRM, basically like the people who would be joining. And we have open channels for communication. So the people who join, they can jump into the conversation and they can start to collaborate. So those are already set up. So in conclusion, the 3 things that we're proposing that is very different from anything that exists out there for saving climate, the data. The first is that we're using torrent as the back end to scale without having too much cost, and decentralizing how we store the information, but also getting these people to participate and have a say. Second is that we're doing verification in a very transparent way. So it's not like academic publishing or this kind of slower process. We're trying to do this as very fast and collaboratively. And the third, what we want to do is to enable micropayments for IoT and environmental sensor producer. So people who actually produce the data right now are not being paid, or they're paid through grants, but it's not sustainable. So what we'd like to do is to virtualize basically those IoT devices, and then pay people who produce the data as well as people who host and people who index. Basically, have an incentivization mechanism for everybody who participates. So that's what we would also like to try. And we want to see as well, psychologically, does it create also perverse incentives? Right now, mostly it's us volunteer doing this. And so it's we're all doing this out of the goodness of our hearts or because we care about the environment. But when we start to have a money component into it, then there will be abuses and there will be people, you know, like pulling it into a different direction. So we want to experiment with this before we scale. So we hope that by having better climate data and better organized, better indexed, easier to access, we will help to build that community of climate data people that will increase the trust, and hopefully that we can build a better world, basically. Thank you. I'll share this slideshow so you can also yourself go and see the slide that you want to see. I put it in the chat so you can all see and comment, and yeah. So Jeff, Alex, what's your gut reaction? What's your questions or?
I have a kind of an abstract question. I was just pulling up like Illustrator to try to sketch out a little game theory diagram. But the question was this, is like if like it's almost like what sort of future does this prevent? What's the bad situation that this prevents? And you know, like any system, you can, especially one that's like a complex system that's interacting with humans and is trying to establish like a position of trust and like is putting in a huge amount of effort. I'm trying to think about what that prevents, or like how we like what's the thing we're trying to, like, that in this modern complex political climate is getting shoved into like a unfortunate position of prominence. What are we trying to like end run around with a system like this? How are we trying to make an accurate, what are we trying to make prevail with an accurate, trusted data set? So you can think about that a little more, but that was my initial question. Is like, what's the end goal once we have this? What comes out of that?
My understanding of it is that the oil companies, they've known for like decades, right, that climate change is caused by their activity, and just like, you know, cigarettes lobby, they managed to sort of blur the playing field and use this just to continue to make more money for, you know, extend a couple more years. And so my perception is that if we didn't do anything, there will be more confusion. So in a way, we're trying to say that we're apolitical, but the fact is that this is incredibly political. And I mean, even if we are like pro-science, the fact that we're trying to make the science surface in this particular context makes it a political thing. So Safecast, if you go on the website, we say that we are pro-data, and our process are very, I think, quite robust. But yeah, even if we say we are apolitical, that's a way that we can, you know, operate. But in practice, yeah, it's, yeah.
So maybe a question for me is, I see there's going to be an incredible number of stakeholders involved in such a project, especially, I mean, that's something, a desired effect, because you want critical mass. You also want a fully distributed system because your kind of question of trust is there. I'm just curious about like the governance model. Like, how do you organize this? You know, like,
Yeah.
there's so much points of failure. There are potential man-in-the-middle attacks. There are so many things that can come up. So I'm curious, like, are you looking at every individual, let's say, scientist as a node within this network? Are you looking at a consortia of nonprofit organizations that help you? Like, I think the governance model for me is something that seems to be the most pressing, because the technology is there. I mean, we talked about this whole SETI at home kind of thing, the distributed computing thing, the BitTorrent thing, all of that makes sense and it's available. You could use, onion sites. There's all sorts of ways to kind of subvert this. You could use Tor, but then the question is still the human factor. Like the technology factor, I'm not necessarily so concerned about because I don't understand half of it, but the human factor for me is the big question. Yeah.
Maybe I'll let Rob answer. So how has Safecast withstand the pressure of dealing with radioactivity data in Japan after like a global crisis? How did you guys manage to
I
steer it?
just feel by being open. I mean, that's the only way it could be done. And luckily, we had enough sponsors to keep us going for 13 years. So I think that's the only way forward. And community building. We did a lot of community building with local workshops and making our data available worldwide. Also for institutes, maybe I'm not the correct person to talk about it. Maybe Aspi will be much better to talk about the Safecast, how Safecast related to basically to the society.
The way I would describe it is that Safecast, even though it had like 5,000 volunteers, I think the core team that makes the key decision is still super, super small.
Yeah.
And so I think
maybe 5 or 6 people, that's all.
Exactly. And so I would say the way that Safecast has dealt with that complexity that Jeffrey, you mentioned, is actually by remaining small in terms of the people who make the final decisions.
Yeah.
And like work in this incredibly high trust, super small nexus of people. I think we were looking during the break, we were looking at the history of Craigslist, which has now become like hundreds of city big network and dealing with like thousands of, and the revenue is 600 million per year. And they have now 50 employees, but it's 50 employees for the amount of data they're dealing with is actually still quite small. So my answer would be the governance, in a way, even if we said they were super democratic, the truth is that it's so far I think Safecast has been pretty opaque in terms of like decision making and very small. And so if we wanted to become really like a really big organization, I wonder maybe there's still the best. I mean, WhatsApp is also like 50 people, right? And they're like valued like 19 billion when they got acquired. I don't know. What would you have like do you have a sense of what would be a preferable strategy? Like being completely transparent exposes you as well to more.
Yeah.
Yeah.
I mean, if I think of just what distributed computing has been doing in the past 50 years, and then what people call whatever blockchain now. I mean, I feel like there's a kind of a medium that you need to find between like a whole bunch of kind of confirming, like infinite amounts of nodes that are confirming your network basically, versus the kind of smaller trusted circle. And I don't know what the medium is, like where you should fall in the middle. But the governance models I see are everything from a consortia of organizations to like every individual person being a kind of part of the consortia. So I think I don't know what the solution to that is, and there's probably way smarter people that think about that, but there's definitely way smarter people that think about that. But for me, that's just something interesting that I would like to see explored, I guess. And I'm sure you guys have explored it. It's yeah, really the governance model is the big question for me. Because then how much power do they have to, like, how does decision making happen? Is like at some point, if you're representing like let's say 1 million climate scientists, but then maybe like 6 people are making decisions on that, is that really kind of a fair model? Yeah,
it's a really good point. To be honest, I don't think we've explored the governance model that much, at least from what I know. And it is definitely like a weak point. The other is the organization governance as well as the process of data verification. I think those two mechanisms are almost the most important because that's what enables the trust. And my understanding of it is that it's still very organic and subjective and individual based on like individual judgments.
Mm.
Yeah.
Even being on the safe cost is the same. It's
Yeah.
still individuals. If somebody makes a strong decision, it's they take the lead.
Mm.
Yeah. If we go bigger, it's almost inevitable that the process will become slower, and innovation and the appetite or the capacity for risk taking will be diminished. From my experience, the bigger the board you make, and the more the harder it's going to be to make any decision because there's more checks and balances. So in a way, yes, it would be fairer, but then also. I was looking at EF, like Ethereum Foundation. It's also very, very small. Like the Ethereum Foundation decision making is very small. They do have, I think, an inner core of high secrecy, but they have another layer of public engagement where you have proposals and EIP, whatever numbers, and they always get reviewed and people can vote on them. But I do think that they don't have enforcement. So it's mostly consultative, which means that people give their opinion. But at the end of the day, they make the final decision whether they want to implement what the community has suggested that they do. So that could be a model, potentially.
Yeah, I mean, I think all the various chains have different reference models that you can look at because they're all attempting to deal with many decision makers, or at least many voters. Maybe changing gears a little bit about the kind of curatorial aspect. So you mentioned that scientists can upload data, and then at the onset, you guys would be kind of going through the data. So for me, the kind of curation of that data, is there decision making in terms of whether this is quote unquote worthy to be on the platform or not? What is the criteria for that? And then the question of collecting data for data's sake. Like for me, like everyone's familiar with the R strategies, and the one favorite R strategy is refuse. And sometimes we're collecting data for the sake of collecting data, and that's fine because we feel that maybe future us or future generations may have a purpose for this data. But in the meantime, collecting that data takes resources, and collecting that data also can act as noise for other data. It may obfuscate other data because we're focused on this particular data. So for me, it comes back to the curation of that data, the custodian of that data, and who gets to decide, or how is it decided that certain pieces of data are worthy to be in the platform and other pieces of data are not, right?
Yes. So far, Safecast was really focused on creating hardware, down to the hardware, to building some of their own communication devices, building custom servers. Everything was under Safecast control. So I think that's the culture right now in Safecast. And so if we start to take on the other people's data sets, recently, like Safecast, maybe in the last 2 years, has been doing like air quality measurements. So we're starting to use like third-party air quality sensor. But as we do this, we are sort of diluting our capacity to be trusted in a way, because we have less and less control. And climate data, for example, like if you say like respiratory diseases related to air quality, this is public health. This is no longer variables of climate. So is this climate data, or is it not climate data? It affects the way the climate affects humans. Is this medical data, climate data? So I don't have a super clear answer for that. My assumption right now is that the way that the culture of hackers that we've had so far is that we build stuff and then we see what makes sense. And
Sure.
so if we build the server and people start to upload some of this stuff, data sets, we will start to aggregate them maybe by categories. And little by little, we will start to see sort of the landscape forming. So that's one organic way of doing it. It's risky because it's not super intentional, and then it's going to take a lot of our resources for in an unknown direction. But I think this is the direction in which we're going right now. I don't know if this is a smart way to go, we should be very clear and set boundaries. I'm not sure. Maybe I'd love to have your thoughts. Like, do you think it's better to have a clear set of criteria, or do you think like the hacker way and just like seeing what people upload is I don't know.
I don't know either. I mean, for me, like, how do you, like, the question becomes, if trust is such a big component of this, how do you just eliminate trust from the equation? Can you make like a trustless system where, you know, via the code, it's kind of automatically, we kind of trust in that, and I don't need to trust in you as a person because I can trust the system. So if the system is designed at the onset to be trustless, as in, you know, it's infallible, then maybe that kind of solves the trust issue, that I don't need to trust that you or the data set or who uploaded the data, because somewhere automatically, you know, the system has kind of removed the variable of trust in the first place. Yeah. Okay, trust, noise. I mean, all of that's leading to security. Talked about like too much data, resource impact, collecting data for data's sake as opposed to curating data. Then I guess for security, there's obviously the tech stuff. So again, you know, man in the middle attacks, etc. But then also the human and social kind of security aspect. Maybe that's another thing to think about. I talked about consortia of organizations versus kind of organization of individual people. And then maybe this idea of live data versus, like, you call that hot and cold data. That creates kind of two classes of data. So I'm curious too, again, like, how do you decide which data is first class and second class? Who decides that, for instance? Is it just based on behavior? Like, if this data is accessed, this cold data is accessed a lot, does it move to kind of a hot data server? You know, if it's not accessed enough, does it move off the hot data server to the cold data server? That kind of mechanism is just curious for me. Yeah.
So I have a couple more thoughts. I'm trying to, like, I feel like there's another level which we're not particularly talking about. So you talk about like surfacing the science, or Cesar, like, or like surfacing the, like, making the conclusions of climate scientists harder to get buried. If I'm paraphrasing you right. But I feel like that's a step removed from the data itself, right? So here, this is one example that came to mind recently, where during the Trump 1 term, there was this famous scenario with Hurricane Dorian, where NOAA predicted that it was going to go into one place, and Trump held a press conference and drew over the NOAA map with a Sharpie and said it was going to another place. And then exerted his influence to try to make NOAA scientists back him up. And so the point here is, this was an attack on the NOAA conclusions, but not on the NOAA data. The NOAA data is still up there. And what Trump was operating at was not at the data level. It was trying to force the NOAA scientists to say, well, yeah, he could have been right. Like the Sharpie thing, sure, why not? And it wasn't, that thing wasn't backed by data. In no way was he trying to go back and change the integrity of the data, but he was trying to change what the scientists themselves, he was trying to change their conclusion by replacing science with non-science, by replacing science with bullshit. So on the other, so this is one side of it, of you know, this is a question of like, not so much what the data is. Literally 0 people went back to check the NOAA data to make sure it was right. You know, what they actually were doing was listening to the conclusions of the data as as it was parsed by scientists, and then this weird fight where the conclusions of the scientists are second guessed and placed under attack by some guy who's has no expertise, who's just using it and saying whatever he likes. On another side, there is a slightly, like another analogy to this, perhaps, was in my mind as we were talking, is how Sci-Hub works, which is just creating a repository of the conclusions of scientists, which is itself a radical organization and which is itself constantly under attack by a huge number of different groups that do not want it to continue to exist the way it does. And this one in particular is interesting because, for example, I've been working a lot with recent science papers, let's say in like machine learning that reference a data set, a particular data set. And something I'll often find is that the paper, if it's more than a year old in machine learning, the data set is no longer valid. The data set will have morphed without the kind of same practices. So I can go through and read the scientists' conclusions, and I can share them, and I can see them either on Sci-Hub or I can go find them on a journal or however. But the core data itself means that I can't replicate their work. And this is maybe a little closer to you of like, the data set itself isn't under version control. There's nothing nefarious happening there. It's just people have created a relatively good culture of version control for things like code. And there is literally zero culture of version control for things like a large data set of blank piles of data. So people are just changing it willy-nilly, and it breaks a bunch of previously existing code, and there's no remedy for that. So it's a little close. I don't know. I think of these two things as like, on one side we have there's the question of where's the data and how is that managed? And then on the other side, there's the question of what does the data mean? And everything I've seen, for the most part, is what you're showing, which is really talking about maintaining integrity of data and maintaining a trusted data model. But what we talked, and you touched on this a little bit last go around of like, can you use an AI model to make predictions based on what you have? And that really gets more, to me, into the public facing side of it, of what does the data mean? And I'd like to hear, like, to me, that I want to hear more about that, or I want to talk more about it, because that's how, in my view, this is relevant to the majority of the world. Even if I'm like a citizen scientist and I am, collecting particular, like, let's say I'm collecting CO2 and methane measurements around me. That's great. What does it mean? I can contribute to the model. I can look at people's raw data. If I don't have the expertise myself, or if I'm developing the expertise, how do I use this information, even this data set that I'm helping contribute to? If I am like a watchdog group that starts to notice that there's a bunch of methane leaks popping up in cities that weren't there before, what do I do with that? How do I use that to either request investigation or action or change? And all of these have this extra bit that isn't really represented in our group here, to the best of my knowledge, which is, as you mentioned, Cesar, like climate scientists who are using this data, or people who are kind of in the layer of thought and intelligence in between the data itself and a conclusion that could be actionable. That's the thing you want to surface. And how you surface it is yet another question. Right now, like this design I see is surfacing the data, which is great, which is valuable, but it's not quite surfacing the science. And I don't think I've seen in the presentation like a way that it would surface the science. I see a way that it facilitates the science by making data available. But I'm curious about, I mean, at the risk of being like, how are you solving climate change, which is like, no one wants to ask that. But really the question is like, there's many layers to it, at least 2 or 3. And the first one, which I think most of this attention, like most of the attention is going into here, is the data. And you can have a perfect source of data and you can still have Trump circling that hurricane and saying it's going somewhere else and casting doubt on it. I mean, this is really what we've seen in climate data is we have an overwhelming scientific consensus, and you still have people casting doubt on it. And my point there is it's not about the data. The data isn't the key thing that's that's making that ineffective or that's preventing action. We've had data. There's piles of accessible data. And it's true, like there's one question of like, is the data itself trustworthy? But I feel like the more common attack isn't on the data. The more common attack is on the conclusions and on the people drawing the conclusions. And I'd be curious about how that kind of fits in, like the second part, like how specifically this bit about surfacing the science. How does that tie into the data set that you're talking about creating? End monologue.
Yeah. No. I think this is super profound and very difficult to answer. I think the way that you do is also trying to answer that question, right? Because you work in education about environment. And I totally agree with you. Like what we're trying to do, even if we have like a perfect data, if we have a perfect map, it still doesn't make necessarily people move. We had this really good interview with this Indian data visualization expert, and she was the data visualization person for Reuters, and she was telling us how she is presenting the data in a way that's clear and communicative, but also emotional, personal, and can provide a base for collective action. And she had a 4-point checklist to make sure that the data is, accurate, but still conveys so trustworthy, accessible, elegant, and tells a story that is personal, memorable, and potentially fun. And I would say at this stage, what we focused on with the team is more like build a very nerdy tool that can help to solve the problem of saving the data. And we haven't really explored yet the visualization and storytelling and how the data is going to be used. So you're pointing correctly at the part that we haven't developed yet. Which is okay. Now you have the data, but data doesn't matter. But yeah, because we are solving the base problem right now, but we eventually will get to the problem that you are underlining.
I guess it's also because the first solution we're giving is kind of like they had this with the previous administration where they did like guerrilla archiving, and it's really kind of creating just this simple basic index first before anything of all of these climate data that we have. But then I was just thinking also yesterday, Josh shared with us one very good example from, I think it was called Carbon Plan, that also shows how you can make the conclusion yourself as to how to read the data, but and we can share a little bit. Okay, QC, can you find it? It's somewhere on the, yeah. And that could be kind of an example. Yeah. Yeah. And this kind of gives a future vision of how things could be, where you're collecting these different sources and laying them out, and obviously people make their own conclusions from there. Yeah.
But what we made as a comment to this is this is very beautiful. It's a very big amount of work, but it's also still very specialized. So it means that the people who are going to be understanding this dashboard are power user, people who are already like deep into climate science and who understand the value of the business, and so maybe it's not our community necessarily, or maybe it is our community, and the climate scientists are super tech savvy, and they for them, like a nice database with an index. If it's nicely indexed, just save them time. Maybe what we are building is a tool that just saves them a couple of minutes a day, or help them to identify new data sets that are coming up or data feeds that are there. Basically, the Google will focus on like environmental data, like making all these data searchable and easy to find and label it and create all these formats output so they can plug that data into their models. Or is our mission further, and we bridge the climate scientists with the general public. And then it's our job then to do this really great data visualization and to enable people to look at their own cities and see how their own city is going to be affected. And so at least it becomes a tool for policymakers or urban designers to like use our tools to. Right now, the way that we're looking at is just like collecting the information, but okay, that's only useful for a few experts. So yeah, if we wanted to reach out to more people, do you think that giving them climate data would be helpful for them? Which is the second demographics? Because right now, the way that we're designing is just for one demographic, is for the climate scientists. Who do you think we should get in the room for these to be valuable or impactful? And I open this question to everybody.
I guess the first question is there's not a climate scientist in the room, or not really a question, but just a point.
Yes.
So I can't speak necessarily for how that would be used. But I guess the next question is, what do you do with the result? Like, if you think about this as a big block diagram where data comes from many disparate sources into a very large, trusted and accurate, like goes through review and becomes a very large, trusted and accurate data set. And then the data set goes into climate scientists, and the climate scientists spit out papers, ideas, models. And that then goes into what? Goes into companies, it goes into politicians, it goes into like, if you think about like these multiple layers, each of those can be attacked, obfuscated, hidden by people who just want to maintain a status quo in a world that is on fire. It's one of the benefits is that there's many different things. One of the benefits of that approach is there's many different things you can do that kind of break a large, complex, interconnected system. But yeah, I bring up Sci-Hub as an example just because, for starters, the results of most climate science data are not even accessible. Most people can't even find and read the paper unless you have a subscription to the journal or pay a large chunk of money, which is the same thing. I'm not asking you to solve another completely unrelated problem. That would be kind of wild. But it is kind of interesting that you have all these folks who have access to the data, and then, how do you, there's this other layer of like a science communicator, somebody who takes their ideas and tries to make them accessible to the general public. And you get many levels through before you get to the point where it's readable by a non-expert, and interpretable by a non-expert. I wish I had more solutions. I only have questions.
No, this is great. What team who's not here was insisting on in the last meeting, and also Kazu, team really insists that the data should be localized. When you are loading Google Maps, you should be centered. The map should be centered where you are, your location. And Kazu was saying that the type of data that we should be prioritizing is the life or death kind of data, like the data, for example, about flooding, about fires, about pandemics, the stuff that people lives depend on. And then Miles, who we've interviewed, he was saying that most of the environmental data projects, they are highly colonial and extractive. People just come and collect the data or get the data, but they don't offer anything back. They just take. And he was saying, like, if you have all this information, make the effort to make an extra layer of information. And this layer should be about helping the group that actually doing something real on the ground. So if you're talking about drought, okay, on the map where you show a drought, also put a little placeholder, a place mark, sorry, which is the detail of the NGO that is helping to dig wells, or that is, the NGO that manage water distribution. If you're doing fire, make sure that you are connected to the firemen and emergency services in your area. So you don't do a humanitarian portal that looks like one, but actually doesn't connect to any humanitarian. So we have those suggestions, and I agree with them, like centering where the people are on topics that are important to them, and not just focusing about the problem and the data, but also lining up solutions. So these are the suggestions that we've had so far, and I think they're all like super on point. But at the same time, what I'm worried is that if we're trying to do something that is complex, it becomes just really difficult. Like how much stuff do we want to do on this one platform? Is what we're trying to do just collecting environmental data, and then other people can build on top of it, and we're trying to do that very well,
I mean, it becomes like just putting on the designer hat. It's a question of the service design, right? So like, what is the journey your various archetypes who are using this platform going to go through? And then that becomes a question of your product development are you creating like tooling? Is this just a series of tools that has no political affiliation? It has no moral or ethical affiliation. It is simply a tool, and it is up to the user of that tool to build a house or tear down a house. Or are you kind of curating and governing kind of this community that is thinking radically about data science, and kind of you're getting them on board, and you need to kind of light a fire in them. And so I feel that these are two different efforts, right? I don't know which one's more desirable. I also don't know which one's easier or harder, but I feel like there's going to be the tooling side, which is really the services that you provide, and then the kind of the organizational side, the kind of social side, and that's like two major challenges I feel for this.
I guess the tooling side actually has an opportunity that it's always going to be neutral, right? We're just giving that platform, and what you do and you choose to do with it, it's not really under us. And in that sense, if anything happens, we can still say we're on neutral ground. But curation and governance, I think looking at this as a business, it's like, who do we partner with from there? And I mean, eventually when we're looking at the business model to make it sustainable, then that might be where it will have to come in.
Yeah.
Maybe in the last session, what we've heard that was the most related to what we're trying to do was Pavlo. So he's the Ukrainian IoT person. So 2 years before the war started, he started to measure radioactivity because we have Chernobyl in Ukraine, and then the war started, and then he had to decide like, do I continue to do like IoT measurements and all the stuff that I'm doing? And he decided to stick with it. And after the Russian invasion, some of the data sets of historical record of radioactivity around Chernobyl actually had been bombarded out of existence. And he was the only person who still had a copy of this data. Even the Ministry of Environment, apparently in Ukraine, didn't have this data anymore. And so technically, like, why would a citizen, take the pain and the money and the time to go and download a government data set? Because we assume that it's the government, it's going to be there, right? And then he still did it. And because he did that, that seems so counterintuitive, he saved a piece of data that's super, super important. So I'm wondering if this is what we're doing as well, like unknowingly, or we sort of have like an intuition that this data is going to disappear, and we're going through all the trouble of doing this. And maybe the reason we're doing this is because we can't rely on government anymore, or on corporation, or on NGOs. We basically have to organize civil society to be more resilient. Maybe that's the reason why we're doing this. We just don't know yet because we haven't been stress tested yet.
And that's an incredible task. So here your partnerships become important. Like, are you going to build like rally people from the ground up, or are you going to kind of rely on, I don't know, professional organizations or NGOs or like a consortium of different organizations that you would partner with to have access to that kind of community and expertise, and also the trust factor, like relying on their trust. And across like different ecosystems, you have different stakeholders that you could vet and potentially onboard. So from the consultancy or for-profit perspective, you have organizations like Metabolic, for instance. From the nonprofit organizations, you have a whole ton of them. From governance model, you could work with one of the chains to kind of give you advice on that. I think here it's going to be the Metabolic is the consultancy. I think Metabolic consultancy, I guess you could probably look up. But there's a few of these types of organizations that you could potentially partner with to kind of explore these challenges. Yeah.
If we do that, then do you think that the story we have chosen to tell is the correct one, talking about the climate scientists saving the data, or should we reframe our audience and say that we are looking at something bigger? Because now this is the framing, but if we're talking about like saving, so the story of Pavlo in Ukraine and saving the data set about in wartime, because now we're going basically
Different stories for different audiences, right?
Exactly.
Yeah.
Exactly. Because the climate scientists, they are such a small group as well. Like there's going to be like what, a few thousand in the entire world that are really like active and have access to valuable data set. It's such a small group. Like it's kind of crazy that we, as a species, we rely on such a small group of people.
Yeah, I mean, so like, nice to meet you, Rob. Have a great day ahead. I feel like again this is where your partnerships are gonna be important, because you don't want to hit every individual climate scientist. You
Yeah.
probably want to hit, like, I don't know, a school of like climate informatics, and then that has like 10 PhD students, 30 master's degree students, and like 100 undergrads. You want to hit kind of like that kind of volume of people, maybe, or yeah.
Yeah, and I feel this is a space where we dream, right? Like right now, you think that because the knowledge is so exclusive to this group of people, then they're the only ones who are left to have to solve it. But if you can unlock it for everyone else, how powerful that could be. And of course, there are like tiers and levels, and we can draw the roadmap. The first thing is, of course, to build that base of information that they can access. But then afterwards, how do we train them and guide them? And of course, that's through having to go through this path ourselves.
Yeah.
Yeah.
Alex, you collect a ton of camera trap data, right? Like maybe you can just say in a few words, like if you had a platform like this, would that make sense for you to use this as a backup of a platform, for example?
Maybe. I mean, on like the current thing I do for backup is I have my data in a structured database that is pointing to a bunch of like Amazon buckets, like S3 buckets. And then I also throw a bunch of stuff, like a bunch of big SD cards end up like getting dumped into a big like RAID array that's my like offsite backup. And that's kind of like, from my point of view, where the data I'm storing is like, kindergartners finding deer. Like this is cool. No one is going to attack the data. Like this is not a particularly, I'm not building it under threat. Nor do I expect like any particular malicious actor in my system. But would it be useful to back up? Or would it be useful to have a place that hosts it? The answer is maybe. So my in my like data model, the thing which points my data to Amazon S3 versus like storing it on my own server versus like putting it somewhere else. Ultimately, it's one line of code. Like in my software, I use a library called Boto S3 that when I upload something to my website, it'll just automatically decide it's going to go here. And I, of course, did a ton of setup to make this system work. But the tool that like kind of collects and decides where that data is going to live and lets me use it like seamlessly in the rest of my code, it's boils down to one single line, which is wild, given, of course, it's a very like ultimately it's an important decision, and I have like many terabytes of stuff on this thing. Um, but it's not the one question is, could you make that data available with the same relative ease? Do I have to restructure an entire data set to work with that? Is there
That's
a tool
points of friction.
Yeah, like that's the other side that like you're, I don't want to say you're necessarily competing with, but you're is that as a developer who's dealing with a ton of like a big pile of code, like I will have to confront this question, like where does my data live? And like Amazon, of course, has paid piles of smart people to make this like nice facilitated tool, which is what I ended up using. For a long time, I just had a server in the closet and I would run everything there. And it's for better or for worse, like it has its own catches to have that stuff on AWS. The biggest one is if I ever want to run a large machine learning model on all of my data, I have to pay AWS bandwidth costs to pull in terabytes of my own data back to my own server and then back again, which I find really irritating. So there's not any one like good answer. It's kind of it is not all these answers have catches to them, and they all have costs associated with in the time it takes to develop them and the like operational costs of using it on. Ideologically, and I understand why it's useful to have an open source data. Like all of our data is publicly available and downloadable and so on, which I think is important. It's just not hosted. It's hosted on someone's commercial platform.
I'm also curious. Oh, sorry, you go.
I think for our service to be attractive to you, one, it would have to be cheaper or free for it to make sense for you to even like consider it. It would have to be guaranteeing reliability, because when you're buying your own server and you put it in your cupboard, it's because you know that it's there and you believe that you have control and this is really important for you. So we need to trust our service enough that you would be willing to put your very precious data there. And then it needs to be practical, because like what you say, like if you have to upload it, download it, and instead of just running a small AI on local, you would have to compete on all these levels. So that seems very unlikely. But at the same time, what I want to say is that if you think about, for example, like the first citizen science project was the cherry blossom in Japan. That's the first recorded citizen science project that I know of. And it's one of the reasons why we understand climate change in the context of Japan, is because we can see that it's been shifting over centuries, the dates of the first day of cherry blossom and the last day of cherry blossom. And because, they follow this by region, and it's well documented for centuries. So we actually have been able to like infer climate change based on observation and manuscripts with a brush. When they were measuring this data back like hundreds of years ago in Japan, they had no idea they're doing citizen science. But because they had recorded this data, we can do this retrospectively. So you may not care about the observation of kindergartner of deers in your location because you think, this is not really important. But in the future, this might be a small piece of something much bigger, which is super valuable.
But that's very focused on archival, right? That they weren't thinking about application at all. They were just very focused on preservation of data. And so maybe that's the first step for you. Maybe it's like, who cares about APIs? Who cares about sharing any of that? Just focus on how do we make sure that we can preserve this data for like multiple generations, it will be infallible and safe and eventually accessible. Because if you're using that as an example, I mean, that's a very elegant challenge. Like, who cares? I don't care who accesses it. I don't care how it's distributed. All of that, that's future generations will figure that stuff out. All I care about is my data is safe, infallible, and eventually accessible. I should also probably knock off because
yeah. Thank you so much, guys. This was super helpful. Those were really great questions, and as you can see, we've taken lots of notes. So this is super helpful. Thank you so much.
Anytime. Happy
What do you
to
think?
continue.
What would you all propose as a good next step to dive into or really prototype? Because I'm thinking definitely getting into the communities of these climate scientists, that's one step. But then also we've opened up this portal of everyone else that can be impacted by this data, and how we can get them on board as well. So I'm just thinking. I mean, I can obviously lay it down, but what do you have anything off the top of your head that you want to see happen in the next few weeks?
I mean, honestly, like I look at your team profile and I feel like the most famous person in your team profile should be shouting about this project on the rooftops and getting everyone on board. And that's probably Joy Ito. Like, I would love to just, he should be at the UN talking about this project. He should be, like, I think a thing like this needs critical mass on two sides. You need critical mass on the people who are contributing the data. You need critical mass of people who are going to be using the data. You have like two target audiences. Then you also have two like systems that you need to develop. You need to develop a technical system. You need to develop a socio-cultural system. That was the governance model I was talking about. How do you? So here you have very kind of two-side double-headed development for so many things, and that can get really complicated, right? So how do you, then it's about prioritizing. And I feel like you should probably take an engineering approach in this case where like the human factor is the most difficult part. I think focus on product. If you can nail the product, then, that's the core offering actually, Yeah. Okay. But it's a pleasure to meet you guys.
Nice.
I'd love to continue the conversation, so please let me know if I can help. Alex, it's like fellow mustached judge. It was nice to meet you too. Yeah. Have a great day, guys.
This is a criteria. We only take people with glorious mustaches.
Wait, let's take a picture. Hold up.
Oh yeah, sure.
Okay. Oh wait, I also want a mustache. Sorry, can I just find? Okay, I got it. Sorry, can I just put on a mustache?
We'll do the We'll do the mustache in post production.
Oh, I'm frozen.
Okay.
Sorry, I guess.
Oh, you found it.
Oh, I found it.
Yes. You got it.
Wait, who's taking it? I'm taking it.
Oh, I don't know.
Okay, I got it.
I got it. Yeah, I got it. Thank you. Have a great day, everybody. Thanks so much, Alex.
Everyone.
Of course, it's good to talk with all of you.
Take care.